in lab before the spring break, we started talking about AC circuits. In an AC circuit, then what happens is you've got alternating voltage. And since you're going to have alternating voltage, you have alternating current. The simplest AC circuit would be one that has an AC power supply and a resistor. And so what happens with the AC power supply is that the voltage is going to be some V naught sine omega t. So it's a sinusoidally varying voltage. And so there we have this AC voltage. And so that means the voltage is, as a function of time, sinusoidal. So to have time and voltage. And since we know that in the resistor that V equals IR, then the current, I, is going to be equal to V over R. And so that means the current is also going to be sinusoidal. And so then say voltage is V naught sine omega t. And so the current, which is going to be just V over R, the current is going to be V naught over R sine omega t. Or we could rewrite that as I naught sine omega t, where omega equals 2 pi times the frequency. I naught is the maximum current. So this is the amplitude, and likewise V naught is the maximum voltage. That's the amplitude of the sinusoidal function. And so there we have alternating current following with the alternating voltage. Graphically, if I were to plot V and time, then we would have voltage like that. If I plot I versus time, then it turns out to be right in sync with that. So the peaks would line up with the other peaks, and the troughs would line up with the troughs. And so they'd be exactly in phase with one. Well, if we're talking about the voltage or the current, one of the questions that we would ask would be, well, what's the power? Well, we know the power equals I squared R, but I keeps changing. So we would say, therefore, that the power being dissipated in a resistor would keep changing depending on the frequency. So often what we would like is just a flat number that says, well, what's the current on average? What's the voltage on average? Well, you can't just take an average of the voltage, because V equals V naught sine omega t. And so if you were to just take an average of that, then what would happen is that the average would be 0. Because, well, after all, the average of a sine is 0. And likewise, the current is 0 on average. And well, obviously, we don't expect the power to be 0. And so we don't want the average current. So if we want to find the average power, it's not the average current. So what we think about this is, well, let's say that we know the problem with the voltage is that V equals V naught sine omega t. And so the problem with that is that the average is 0 because the signs were positive and negative. So one thing we might think of is, well, what about V squared? V squared is V naught squared sine squared omega t. Well, sine squared is always positive. So an average of that would always be positive. And so we can just go ahead one step further and say, V naught squared sine squared theta. So theta equals omega t. And so we say, okay, so we want to do an average of that, an average over time. So the average over time would be like the average over one period. Okay. And so one period would be when theta goes from 0 to 2 pi. Okay, so if we want to find the average of this, well, to find the average of it, Okay. The average of something like this, we have a function here, and we want to find the average value. So how do we find the average value of a function? Well, in calculus, that's the mean value theorem. Mean value theorem would say that the average value of that function, so the average of the v squared, so I want to find v squared average, that's going to be an integral over a range. Okay, so the range would be the integral of v squared sine squared of theta d theta, and I want to go from 0 to 2 pi, but it's going to be 1 over the range. Okay, so 1 over the range times the integral across the range of a function gives the average value of it. Okay, so we remember that from the mean value theorem of calculus. Okay. All right. So I want to find this average of the v squared. So we can bring the v naught squared out over 2 pi integral of sine squared theta d theta going from 0 to 2 pi. Okay. Well, here's the interesting thing. If you actually do that integral, the integral from 0 to 2 pi of sine squared theta d theta turns out to be pi. Okay, so average of v squared equals v naught squared over 2 pi times pi. So the pi's go away. Okay, and so that means that this is going to be 1/2 v naught squared. Well, then we look at that, we say, well, wait a minute, if that's the case, then we don't want really the average of the square, we want the square root of the average. So if we take the square root of the average of the square, then that's going to be the square root of v naught squared over 2. In other words, this is going to be equal to, that's going to be equal to v naught over square root of 2. Okay, so this is the square root of the average of the square. So this is the root mean square of the voltage. So what does that mean? The root mean square of the voltage. So VRMS, we can call this VRMS. The VRMS is equal to the amplitude divided by the square root of 2. So for example, the outlets in your home are 120 volts RMS. Okay, so that's going to be the amplitude divided by square root of 2. So that means the amplitude of the voltage in your house is going to be equal to 170 volts. Okay, so that means if you make a graph here of the voltage in your house, it goes from 170 volts to minus 170 volts. Okay, and it does that in 60 times a second. And so what we would say is it averages 120. Now, why do we do this sort of thing? So that would be so that if we had a simple circuit right here, okay, so this right here is 170 volts times the sine of omega t. Okay, so omega is going to be 2 pi f. F is 60 hertz. So that would be 120 pi hertz. Okay, and if this were a 10 ohm resistor, then we would say, what's the average power? Well, the average power is I squared R, but we want to find the average I, so we use the IRMS right here. And so that means that the power would be the IRMS squared times R. Okay, or that would be the VRMS squared over R. Okay, how did I get that? Well, I equals V over R. So I plug that in, and so that would give the V RMS squared over R. So that means that this would be equal to 120 volts squared over 10 ohms, because that's the RMS value of this. Okay, so 120 volts squared divided by 10 ohms is going to be 1.44 kilowatts. Okay, so this is why we use the RMS value, is it gives this sort of time average deviation from zero. And so this is how we deal with resistors in AC circuits.